Divide your class in groups of 5 to 6 students each. Pull the cards prepared by the students in your group. Observe various features of plants and animals shown on the cards. Recall the features of plants and animals that you have listed in tables 2.1 and 2.2. Group them on the basis of common features. Share and discuss the basis of grouping you have made with other groups in your class. You will be surprised to see that the bases used by different groups may vary. What do you think are the reasons behind it? Different students might have chosen different common features for the grouping. For example, some students may have chosen the height of plants as the basis for grouping while others might have chosen presence or absence of flowers as the basis for grouping of plants. See Fig. Though the flowers, hard soft stem, eating habits, place they live curiosity textbook of science grade 6 solar. S. No. Name of the plant height nature of stem appearance of. As what they eat, where they live, what color they are and how they move. What is the importance of grouping? Grouping makes it easier to understand and study plants and animals on the basis of their similarities and differences. You will learn more about the importance of grouping in our daily lives in the chapter, Materials Around Us. 2.2.1 How to Group Plants. You must have noticed that plants show variation in the features related to stems, leaves, flowers, and more. The stems of different plants vary in thickness, height, and hardness, while the leaves vary in shape, color, size, and arrangement. You might have tried grouping the plants in Activity 2.3 using one of these features. You might have also learned in earlier classes that plants can be grouped into herbs, shrubs, and trees based on their height and types of stem. Let us study the features of plants in more detail and group them on that basis. Activity 2.4 Let us group. Let us go on a nature walk again for some more interesting observations. Look closely at the heights of different plants. Are these plants shorter than you, as tall as you, or taller than you? Is the stem brown or green? Touch and feel their stems and try to bend them gently. Can you bend the stem easily, or is it stiff? Take care that stems do not break. Also, observe from where the branches of the plants arise, whether they rise close to the ground or higher up on the stem. Fill in your observations in Table 2.3. A few examples are already given. Fig. 2.2 Some possible criteria of grouping. 2.3 Grouping of plants based on height and nature of stem. DIVARSITINTHALIVING word. Satra. Fig. 2.4 What differences do you observe among herbs, shrubs, and trees? How can you group plants as herbs, shrubs, and trees based on the data entered in Table 2.3? Some plants grow really tall and have hard, thick, brown, and woody stems. Their branches typically start higher up on the stem and away from the ground. These plants are called trees. For example, a mango tree Fig. 2.3a. All plants are not as tall as trees. These plants often have many brown woody stems that start branching very close to the ground. These stems are hard but not as thick as the stem of a tree. These plants are called shrubs. For example, a rose plant is a shrub Fig. 2.3b. Some plants are typically small with soft and green stems. These are known as herbs. For example, a tomato plant is a herb Fig. 2.3c. Some plants with weak stems need support to climb and grow, and are called climbers. Some plants creep along the ground and are called creepers. What can be other features on the basis of which you can group plants? Let us perform another activity. Activity 2.5. Let us look at the leaves of different plants collected by you during the nature walk. Do you notice the variation in the shape and structure of these leaves? You may observe thin lines on the leaves of the plant's Fig. 2.4a. These are veins. The pattern of veins on the leaf is called venation. What differences do you see in the veins of leaves shown in Fig? Fig. 2.4 and Fig. 2.4b. In some leaves, you can observe a net-like pattern of veins on both sides of a thick middle vein. This pattern is called reticulate venation. For example, leaves of hibiscus exhibit reticulate venation Fig. 2.4a. In some leaves, you may observe that the veins run parallel. This pattern is called parallel venation. For example, the leaves of banana plants and grasses exhibit parallel venation Fig. 2. Or you think that plants can be grouped on the basis of venation present in their leaves. Now, let us try to explore roots of the plants. Do all plants have roots? Are these roots similar? Activity 2.6. Let us find out. Visit an open area where wild herbs and grasses are growing. You may use small herbs for this exercise. Using a herpy trowel, carefully dig out a few different herbs without damaging the roots. To do this, you may wet the soil and loosen it. Wash the roots with water and observe them. After you are done observing, make sure to replant the herbs so that they may continue to thrive and grow. What are the similarities and differences in the roots of the plants collected by you? What differences do you see in the roots of plants shown in Fig. 2.5 and Fig. Observe carefully the roots of a mustard plant in Fig. 2.5a. The roots of this plant consist of one male root and small side roots arising from it. The male root is called taproot. Another example of a plant having taproots is hibiscus observed by you in Activity 2.1. The plant in Fig. 2.5b is a common grass plant. The roots of this plant appear as a bunch of similar-sized thin roots arising from the base of the stem. Such roots are called fibrous roots. Fig. 2.5b. Does your collection include any other grasses? What kind of roots do they have? The type of root of the same plant. How do we find this out? Activity 2.7. Let us relate and analyze. Collect saplings of 5 common plants from your school nursery or any other nurseries to plant in your school garden. Examples of such plants can include lemongrass, marigold, sadabahar periwinkle, and others. Before planting them, observe their roots and the venation in their leaves. Record your observations in Table 2.4. Table 2.4. Types of leaf venation and roots. S. No. Name of the plant. Type of leaf venation. Reticulate parallel. Type of root. Fibrous tap. Egg. Lemongrass parallel fibrous. दो, तीन, चार. Types of root in these plants. A sadabahar plant has a taproot and its leaves have reticulate venation. Do other plants with reticulate venation have taproots too? Lemongrass, on the other hand, has fibrous roots and its leaves have parallel venation. Do other plants with parallel venation have fibrous roots too? Generally, plants with reticulate venation have taproots while those with parallel venation have fibrous roots. Chickpea chana is another example of a plant with taproots and reticulate venation in leaves. Wheat is an example of a plant with fibrous roots and parallel venation in its leaves. Tea and leaf venation. Are all seeds similar? Activity 2.8.
आगे का जो नेक्स्ट क्लास में करेंगे।